The weight of a diamond is measured in carats. Okay, that's a statement. Because we're going to weight of diamonds measured in carats, right? How many pounds does, oh, good Lord, a 5.7 5 carat diamond ring weigh? It wants to know how many pounds that is. And we got 1 carat. Okay, so 1 carat equals 200 milligrams. So how many of you ladies would like to get that ring? Nobody? Right? I mean, it would almost be too big to have 1 diamond. I mean, 5 carats. You guys realize that, right? I mean, that's huge. Okay, so we're looking for what? How many pounds that weighs? So what do I want to do? I want to start out with 5.75 carats. And start building a shell. Now, you always kind of want to start out with what you've got, right? Because like I've told you before, the more ink you get on that paper, the more likely you're going to work a problem. Now, I've got here the conversion factor of 1 carat equals 200 milligrams. Now, I know that we are nowhere near a pound, okay? But we've got to move through it slowly. Now, as you go in the back of your chapter there in your cheat sheet on your conversion tables, what kind of conversion do you see between a pound and a what? Well, okay, you can see a pound and a kilogram. Can you see anything else? What about a pound and a gram? Do you see that? Okay. So, how can we get from milligrams to grams? Does anybody have any ideas? What's that now?
10 to the power 3.
Okay, so you want 10 to the 3. 1 times 10 to the 3 grams in 1 milligram? The other way around? Oh, you want a negative 3? Is that what you want? Okay, so remember, you're looking at the table in your textbook. Okay? And remember, every chemistry person does it different when they write their textbook. And the way it's written in this table is as follows. The number in the table goes with the single letter. Okay. Now that means milligrams are gone, so now we're in grams. Okay, somebody with a bright idea. Can you get me from grams to pounds? $453.59 grams in a pound. Have you located that? Okay, so are we there? We're there. Okay, so let's pull out our calculator and see what we get here. Okay, we're going to take 5.75 times 200 times 1 times 10 to the minus 3 divided by 453.59. Hitting the enter button and I'm getting an error. What is going on? I see why. Okay, 5.75 times 200 times 1 times 10 to the minus 3 divided by 453.59. What are you guys getting? .0025 pounds, or 2.54 times 10 to the negative 2 pounds. Now, does that make sense? Think about it. You would think that a ring, right? I mean, if you guys can envision a pound, I mean, you would think that a ring would not weigh a pound. I mean, that would certainly be strenuous on your finger. Okay, now even, I mean, you know, a 6-carat diamond is not unheard of, like if you were in movie stars, Hollywood, these type of things, right? Maybe it's unheard of for a normal human being. So, I mean, you certainly could picture that. It would be out of control, all right, but especially on a teacher's salary. But I would buy that, 2.54 instead of minus 2. Did you get that? Yeah? Did you just think it kind of seemed like a low number or what? Yeah? Okay. Does anybody have anything else on these conversions?
On the test, are we going to have to write things out in scientific notation, or would that be acceptable?
No, either one's acceptable on my test, freshman chemistry. Yeah. Again, you know, my philosophy in teaching this class here is this is a wonderful high school to college bridge where it's more important, in my opinion, to get the concepts, the procedures, instead of worrying about significant figures. I mean, here I did the significant figures for you. There's 3 sig figs there, there's 3 here, all right? But you know what? Some joker didn't put the 4, something like that, whatever, okay? I just really like to see the process at this early on. Yes, ma'am?
Number 20A.
20A. 20A. Okay. 4.5 centimeters to angstroms. Didn't we work that last time?
You worked it?
Yeah, I think I worked that one last time. Does it make anything else?
Oh, never mind. I see it.
Okay. Well, chapter 3. This will be a wonderful change for some of you, right? Who kind of likes this math? Anybody? Got one person? I did too. That was my favorite part, is I really liked the math, right? The girl with the Alabama shirt, right? I'm not going to hold it against you. But chapter 3 is a periodic table. And it's not the entire periodic table. The name of the chapter is really the elements and a little bit how they come together into compounds. But we use it as a way to introduce the periodic trends and the periodic what they call laws. Now when we say periodic laws, what we're talking about is we're talking about trends and hidden information inside the periodic table. So you may say, well, why is this periodic table in every single science classroom? Well, here's why. There can be books written about the information that's hidden in there. Things like electronic structure, how things react, different types of masses and nuclear structure. I mean, there's all sorts of things that you can talk about when looking at the periodic table. So this chapter is just a way to introduce that. Now, first off, how many elements are they that we know of? There are approximately 118. Okay. Now, that number does change from time to time. Here's why. The elements kind of to the right of 111, okay, well, first off, the elements from 104 on, those things are synthetic made, all right? And that means that the only way you're going to find those that we know of, okay, is coming off of nuclear reactors, particle accelerators, colliders, and all of these type things. Now, one of the things is you can go out and you can find zinc and you can find aluminum in the atmosphere, and it's rock hard stable. You can bring it to the lab and you can study. You can put it on the shelf, study it 10 years later, whatever. But see, some of these little things right here, they might exist for microseconds or even nanoseconds. So how do you even know that they exist? Well, physicists and chemists have techniques that we can use to figure out if they exist. But the problem is there's a couple of competing laboratories. You know, people at UC Berkeley or Lawrence Livermore, people in Chicago, they may go back and forth and say, well, we don't think so, and somebody else, we think so, here's why, there's why, so there's ambiguity. Now, once something is named, there's no ambiguity. Okay, so something like seaborgium as an example, or borium, or one of these things here that actually has a name, those have been well documented, and there's generally not a bunch of hubbub about their existence. Now, here's the thing. In a periodic table, you have abbreviations and you have names. Okay? Now, anytime there is a one-letter abbreviation, it is capitalized. Now, before we get even started here, you know, I just got through talking about how I was slacker. Okay? I did not pay much attention to significant figures, which I don't. But when it comes to abbreviations, I'm not a slacker, because that's very important. For an example, if you see on a bottle this,